Hooray, we have internet. Hallelujah. That's always a scary thing on the first day of class to, run into technical issues like that. But let's go ahead and get started. So I'll give you guys a couple seconds to get in here. But we're going to be starting our chemistry journey today. Let's see. So hopefully you'll be in the right place, right? This is C101. That's going to be our intro class. If you are in one of the more advanced ones, those meet later in the day. So 113 will meet at 10:15, I think. So, but if you're in 101, you're in the right spot. So let's go ahead and get started. We're going to start by kind of covering I do game, but both, I guess. But we'll have some time for that towards the end today. So we'll just talk about chemistry for a bit, and then we'll spend maybe the last 15 minutes or so doing kind of introductions and that sort of thing. So we'll get there. So chemistry for us is going to be, yeah, exactly. So chemistry is the study of matter. And sometimes people also include energy along with that. So pretty much everything in our universe is going to be composed of either matter or energy. So we are really studying everything here in chemistry. So that doesn't really help narrow it down, does it? But we're specifically interested in kind of physical kind of characteristics of matter and how we can predict how we can change matter. And that's kind of what we're going for here with chemistry. So first things first, we're going to have to kind of define that. Hello, good morning. So what the heck is matter? Matter's kind of, again, it's this kind of abstract thing, but for us, it's going to be pretty easy. We're going to define matter as anything that has mass, and that means there's an amount of matter that's associated with it. So for example, this stylus thingy here has a certain mass to it. I can go ahead and weigh it and find out what that mass would be. It's got a certain amount of matter associated with this particular object, and it has a volume, which means it takes up space. So everything that will be matter, good morning, will take up space and will have mass. So we'll have an amount of substance, that would be my one stylus here, which is made of however many atoms and blah, blah, blah. And it takes up a certain volume, that's this amount of space, really. So that's going to be how we'll define matter for this. And so everything else will be energy. So everything that you can think of that is a thing will be matter, and everything that is basically light and heat, that's going to be most of our energy that will associate. So there are our first definitions. So hooray, we've survived the first vocab lesson for chemistry. So we're going to continue on then, talking more about matter. Let's switch colors because I feel like it. I don't know if you can hear Oz growling down there. He's mad at something. I have a bunch of dogs, so we'll periodically hear them grumbling and, borking here and there, so we'll see. By the way, as any questions come up, just throw them in the chat there, and yeah, I'll be able to answer them. So, with regards to matter, we can talk about kind of characterizing matter. So matter is everything that is kind of touchable, right? So, yes, Oz, calm down, buddy. We can classify matter by looking at what it is made up of. So we can have kind of two main categories. We can call things pure substances. If I can spell these things right, which of course I never can. We can have pure substances, or we can have mixtures. And we can kind of think of these as one thing. Creature, relax, buddy. What are you doing over there? It's always a good start, right, to the semester when the dogs decide to go nuts, you know, as the internet is down. It's always a fun start, right? And then a mixture would be more than one thing. So for an example, one pure substance would be something like water, whereas a mixture would be something like milk, where it is made of more than one thing. Right, water was just kind of one molecule, as we're going to find out. That's H2O. Milk is made of hundreds of different molecules and various ions and things. So there's a lot more than one kind of thing going on in milk. So milk is going to be classified as a mixture, and water is going to be classified as a pure substance. So it turns out we can, in fact, break these down even further. Within pure substances, we kind of have two categories even further. We have elements and we have compounds. And just like before, where we had kind of pure substances were one thing and mixtures were more than one thing, with elements, those are going to have basically just one atom type. If you've never heard of an atom, which is kind of tough because they're talked about all over in pop culture and you've probably taken science before somewhere, we'll define an atom a little bit later, but for now, just bear with us, I guess. And compounds will have multiple atoms. And so, if we want to think about our example of the pure substance before, that was water, that's going to be a compound. For example, that water has a chemical formula of H2O, which is going to tell us that we have 2 hydrogens and 1 oxygen. We'll learn about these sorts of things later. Another example would be like salt, which is sodium chloride. Let's see, what other compounds do we have? How about sugar? That's got a pretty crazy formula. That would be sucrose there. So you can see we have different elements in here. Doesn't matter how many of those we have. For example, the sugar has tons of different atoms going on. The salt just has 2 different atoms. Doesn't matter, as long as there's anything that's not the same, we're going to have a compound. An element, though, would be something like titanium or oxygen. Oxygen always occurs as O2, by the way, but we'll learn that in a little bit. Sodium by itself, copper, iron, carbon. These are the easier ones to identify, right? Because we could just pop over to our periodic table and just find them on there, and we would be able to identify those as elements. So as long as you've got just one type of atom, you're an element. If you've got multiple types, you are a compound. Hooray! Any questions so far on this exciting vocab lesson on day 1? Here, let's put another one. Nope, you do not need to be in Discord right now. Mostly we're For Discord, how we're going to be using that, mostly it's going to be for chatting. So it's where you're going to be asking questions and where we're going to do our like participation stuff. On review days, though, I may pop into voice chat on Discord so you can ask questions directly that way, if that works, if you want to do that. But that'll be a few weeks out. So you do not need to be in voice on Discord for this. So, yeah. Alrighty. Cool. Oh, I see. Let's have a look. Let's pop open. Ah, I see. Okay. Ah, okay, so someone else had a power outage. Let me just type out here, disk voice for reuse sessions. Okay, there we go. So hopefully they'll figure out where to go. But even so, you can always watch this later. So, and plus it's the first day, like we're expecting, you know, things to go awry. So, but that's all right. Cool. Well, with that in mind, let's go ahead and look at some mixtures. Hopefully that'll get the people in Discord moving. Well, let's see how many do we have on Twitch right now. Well, I guess I have no idea. We have 14. It's actually pretty big for the amount of students in the class. Usually about like 15% or so can make it to the live lectures, so we'll see. But any of you who have come in a little bit later, don't worry, you can always just rewatch the beginning. We haven't really done very much so far. So we've just been talking about matter. We've classified a little bit of matter. We've seen things as could be elements or compounds if they're pure substances. Pure substances meaning they're only made of one thing. Hi, Anne. Nice to meet you. And you're lucky you even got your name as your Twitch handle. That's awesome. For mixtures, we can have two types. We can have homogeneous mixtures and heterogeneous mixtures. And how we'll kind of define those, just like before. Oops, do I like this one? I don't remember. I think so. No, that's way too big. Boop, boop, boop. Homogeneous mixtures will be completely uniform. That means the same throughout. And the heterogeneous mixtures, or heterogeneous, would be not the same. So if we take a look at some examples of those, a heterogeneous mixture would be something like a salad. For example, you've got, you know, like lettuce and tomatoes and croutons and carrots and I don't know, whatever else you have in your salad. If you take a bite of that salad, you're going to see that each bite will be different, right? Maybe one time you'll get 2 croutons, maybe you'll get none in the next bite or something. So it's not the same throughout. You can see distinct different parts of that mixture. And you can say, okay, this region of the salad has more lettuce than the others. You know, something like that. Or something like ice water. If you have a glass of ice water, which I do not have with me right now, you'd be able to see, okay, I've got chunks of ice over here at the top. I do not have any ice at the bottom. Maybe it's colder at the top. It's warmer at the bottom. It's different somewhere in that mixture. And so we can kind of see that we have different things going on there. On the other side, homogeneous mixtures would be something like milk, like before. Wherever you take a sip of your milk, it's going to be exactly the same throughout. Or something like salt water, where you have salt that's completely dissolved, you're going to have it be completely the same throughout that mixture. Or something like honey would be one, or steel, or styrofoam, if I can spell that. Styrofoam. Let's see, some other heterogeneous mixtures. How about this pen? A pen is a heterogeneous mixture, right? You have an ink thingy in the middle. You've got your little like ballpoint thingy. You've got the plastic casing. You've got the cap. You know, you've got all these different components there. You maybe have a spring inside, and like the pushy button on the top. You've got all sorts of different things happening there. So most things, in fact, we're going to see will be heterogeneous mixtures. You know, your computer will be one of those. You know, your human body, right? We have different cells all over the place. You know, I've got hair over here and, you know, not in my intestines, hopefully. Though living with dogs, there's probably hair in everything I eat, but there's nothing to get around that. Come here, buddy. All right, someone wants to come say hi. So we have my oldest one here. He's begging to come up, so he's going to sit on my lap. So you're going to meet all of them over the course of the semester. So this one is Oz, by the way. So there will be a test at the end of the semester to see how well you've learned my dog's names and personalities. So make sure you write that down as well. Kind of joking. Alrighty, cool. Any questions on these mixtures? Or if anyone has, you know, like, hey, is this one kind of, you know, vague? Is this one homogeneous, heterogeneous? Anything like that? If you want to put any other examples in here. Alrighty. Very good then. Let's move on to another component of matter that we've talked about. The first, you know, lecture or two are going to be kind of real basic. So hopefully there shouldn't be too much trouble with any of this stuff here. A lot of it you will have probably already seen before in previous classes, or just, you know, in, you know, having seen television or something. Somewhat. It can be either one. Yeah. So it could be chemical or physical that these things are different for these sorts of mixtures. Oftentimes we're going to see that physically it's going to be easier for us to determine what type of mixture it is, but sometimes there are chemical components that help things kind of become homogeneous. For example, milk or mustard or something has, you know, they have these emulsifiers in them that allow things to mix where they normally wouldn't be able to mix. And so they can kind of make heterogeneous mixtures homogeneous. But we don't have to worry about that. So any sorts of questions I would ask you on this sort of thing, they should be super obvious to us, hopefully. Like if I ask you a chocolate chip cookie, you know, you should probably say that's heterogeneous, right? Because you're going to have some areas that have more chocolate chips. Sometimes they'll have less chocolate chips, or whatever it may be. So, yeah, you can have both chemical and physical differences there, for sure. But mostly it's going to be physical stuff. Alrighty. States of matter. These ones you've heard about. Solid, liquid, and gas. We're not going to talk about plasmas or supercritical fluids in this class. So luckily for us, we'll only have to deal with 3 states of matter. And we're going to be now comparing all of them. So let's think about these 3 states of matter. And let's see what we can kind of come up with regard to kind of properties they have. I can kind of start us off. We can think about solids as being kind of rigid, right? If you think about something that's solid, you kind of think of it as sturdy or kind of rigid, right? But what I mean by that is that we have a defined shape. So this pen, or stylus, whatever it is solid, right? It has this particular shape. If I were to move it slightly to the left, or for you to the right, it would still be the same shape, right? Or if I tilt it, still the same shape. Or if I throw it against the wall because I'm frustrated by the lack of internet this morning, it'll still be the same shape, provided it doesn't break in half. So we're going to see that solids are going to be kind of easily identified by the fact that they hold their shape. And so that's going to kind of be our most defining characteristic for solids. Liquids and gases, though, do not have defined shapes. I can't even spell shape. That's how undefined these are. If I were to take my coffee, which is now in the shape of this particular mug, if I pour it into a different mug of a different shape, it will assume that other shape. Or if I just pour it onto the floor, it will just kind of spread out. Right? I'm not going to do that because I don't want to clean that up. Plus, I don't want to waste coffee because why would I do that? So liquids will not be able to hold their shape. They will assume the shapes of their containers. Gases will be the same way. If I take a balloon full of, let's say, nitrogen dioxide or something that's got color, like a brown gas or something, it's kind of a brownish reddish gas, and I pop that balloon, we're not going to just see an orb of brownish gas anymore. It's just going to completely spread apart and kill everyone because it's a poisonous gas. But it would eventually just take this the shape of the room that I'm in if I were to pop that horrible balloon. So we're going to see gases don't have shapes either. Alrighty, another important characteristic for these is going to be that solids will also have, whoopsies, defined volumes. So that means this pen, which takes up a certain amount of space, no matter what I do with it, it's going to still take up that same amount of space. You know, not much can be said there. I can't really take this pen and like really push hard on it to try and make it smaller or something. Not really going to work, right? It's kind of got this defined volume. It's going to take up the same amount of space wherever I put it. Unfortunately, you know, if any of you are hoarders, you know, the clutter will take up space, you know, no matter what. Can't really get rid of that problem. Unless you hoard gases somehow, then you'd be able to get away with it. But unfortunately, we're going to see that liquids and solids will not be able to kind of hide their volumes, as it were. They'll always take up space. So, fun fact, if any of you have fairly young children, I think younger than 7 or so, you can play a little trick on them. Take 2 different glasses, you know, put water in one of them, and pour it from one glass into the other, and ask the kid to tell you which one has more volume. And often enough, the children will say it's the taller glass, even if it's narrower. And even though if you just poured the liquid from one to the other, children will typically say that whatever the taller glass is will have more volume. So it's pretty interesting. However, once they grow up, they do learn that volume is conserved for liquids, which is pretty fascinating psychologically. That is part of our development, but it is pretty fun to toy with kids in that way. So try it out. Take a tall glass and a wide glass and compare them and trick your kids. So, but for us who are presumably all above 7 years old, we're gonna see that. Yeah, no worries. There's no requirement for attendance, so you can just watch the rest of this later. So no problems. enjoy calculus. So yeah, mess with your kids. That's the point of the lecture today. Gases, of course, will have no defined volume. So if you pop your balloon full of toxic gas, it will spread across the room pretty quickly, and then kill everyone in its path. So we're going to see that gases will not be confined. They will always take the shape and volume of their container, whether that container is an atmosphere or a room or a bubble or something. Gases will just kind of adopt the shape of wherever they are. So, cool. These are kind of our, third grade basics that we've seen in real life. But now we can talk about more kind of chemical stuff going on here. We're going to see that in solids, we have atoms are going to be close together, and they're going to be tightly packed in solids. And so we're going to see that, maybe you've thought about this before. We're going to see solids are going to have these kind of nice, really close together atoms. So these little circles here are our atoms. For liquids, they are also close together, but they will flow past each other. So for a liquid, things are going to kind of be a little bit more disorganized. They're still going to be pretty close together, but we're going to see that, they're just in constant motion, and they're just moving around each other. Hopefully that's enough arrows to get the point across, but they're going to be just moving around each other, atomically speaking. And then for gases, we're going to see that the atoms are going to be super far apart. They're still going to be zipping around. And maybe this one's going here, that one's going there, that one's going there. Wherever they're going, but they're going to be super far apart. That's going to kind of be the defining characteristic of a gas. They're going to be super far apart from each other, and that's going to be how we can easily distinguish gases. One thing to note that in solids, they're not completely still. They are just going to be vibrating in place. So they're just vibrating. I don't know how to describe vibration. I'll put these random dots. Maybe that'll be how we'll describe vibration. So they're just kind of like, bzzz, constantly. So they're not really moving really past each other or anything like that. They're just kind of sitting there, just vibing. They're just kind of like, yeah, this is fun. I like being a solid. And liquids are just swishing, moving around each other, and gases are just zipping all over the place. Super far apart. Alrighty, one last thing about solids that we'll talk about is that solids, especially, they can come in kind of two forms. We can have crystalline solids or amorphous solids. And for this, I'm going to go ahead and switch to the to our best friend Google here, because Google can draw a lot better than I can. So let me just pop open a new window here. Aha! So here's a lovely picture of what I mean by this sort of thing. So amorphous solids are going to kind of be a little bit more disorganized. Actually, I kind of like this one more. Let's look at this picture. So amorphous solid, we can kind of see that these are not necessarily orderly like they are in a crystalline solid. In a crystalline solid, everything is nice and ordered and repeating and organized and pretty. In amorphous solid, things are kind of randomly in there and they're just kind of going whichever way they want to go. So, back to this. These are going to be kind of orderly, and this is going to be kind of chaotic. Awesome. So, we have talked about now how to classify matter, and we've also talked about states of matter. Any questions on any of those? I again realize that a lot of this stuff is probably stuff you've done before, but still feel like I should ask just in case. And just so you know, since I do get this as the start of the semester, I am the sort of instructor who does not mind that you ask the same question 5 times. Go right ahead and do that. If something is not clicking, I will try my best to get it to click. So if I have to say the same thing, 10 times and try it different ways, I'm happy to do that. So I'm not going to get mad or anything like that. Of course, some instructors do get weirdly upset if you ask questions, but then they're not doing their jobs, right? So, alrighty, cool. All right. Well, that's kind of as far as I wanted to go with content today. So, with that, I do have our kind of first participation assignment here. In Discord, we are going to answer the following questions this week. So for the first 2 weeks, we're going to have kind of like participation prompts because the state says that I have to take attendance, which isn't really possible with an online course. So for online courses, we have to do a sort of like proof that you're alive and participating, just the laws. So this is going to be how we're going to do that. So first thing, you're going to introduce yourself. That would just be, your name, whatever you like to go by. Second thing you're going to do is you're going to answer this. You're going to answer if you've taken chemistry before. And the third one is you're going to say, or answer, what do you do for fun? Idea here is, maybe perhaps you'll find some co-interests with other classmates that, just maybe something that, you can kind of bond over or whatever. Online courses, it's particularly tough to kind of feel like a classroom community, but we will do our best to kind of mimic that. So, let me see here. I know I have one of these that's Discord. You're going to write this in the general channel. So, I will try and remember which window. Let's just do a new one. How about that? Aha. Okay, so for this, you're going to be writing it right down here. Ta-da! There you go. I have answered the 3 questions. And hopefully you understand I'm joking about never taking chemistry before. But this is going to be our kind of participation for this week. That's all we're going to do. In Discord here, this is going to be also where you will put questions. So if you say, not David, sorry. Is, okay, I have... chances are what you will need to do is come here and click the camel. You should be given the text or the welcome channel as the first thing when you click Discord. Go ahead and click this camel here. That's going to give you access to the general channel. Or I can just assign it to you manually. But I'm not sure who you're going to be here. So hopefully that'll help. Cool. Awesome. 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 All right, we've got Ted here. Awesome, awesome. Amber doesn't like to have fun. Oh no, that's sad. Baseball is fun. Come on. Yeah, no problem. Happy to help there. So that's all we're going to be doing for the rest of today. So that's fair, but you gotta do something to de-stress, you know? So this just kind of last bit. There's not going to be any more chemistry, so if you want to get out of here, you are more than welcome to. Yeah. Edward, go ahead and change your nickname for me, if you can. You can do that on the right side here, somewhere, wherever you are. If you go ahead and click change nickname, it's going to just make it easier for me. If not, I will ban you. No, I'm not going to do that. But perfect. Awesome, awesome, awesome. Great, great, great. But yeah, that's all we're doing today. So if you guys have any more questions, go ahead and... Awesome. Yeah, thank you, thank you. Just go ahead and answer this stuff here. Yeah, it'll be your participation. Tomorrow we'll continue on with our chemistry. We're probably not going to have any homework this week because we're not really doing anything besides kind of this introduction stuff. And so we'll probably have our first assignments next week when we start talking about doing math in chemistry. Awesome. Awesome, awesome. Oh my goodness. Well, welcome back to chemistry, Emily. You may totally start doing that. We're going to be on chapter 1, and we're maybe going to start 2A this week. So, Edward, that's totally up to you. I think it's a good idea to read the textbook, just because it'll give you kind of another view of the same information. Probably not going to have a huge difference this first kind of week, but once we start getting into doing math and stuff, there's going to be a lot more practice problems in there that you'll be able to take advantage of, other than the ones I can give you in class. So yeah, so cool. Miniature houses, that's an interesting hobby. Sarah, what do you make those out of? Is it like wood crafting or like popsicle sticks? Oh, okay, it's like okay, that's awesome. Oh, I remember you, Cassie. That's right. That's right. That's right. Though hopefully not at 9 in the morning, right? Yeah, that's right. I remember. Congratulations. Yeah, having a baby during chemistry is not an easy task. That's right. Oh, by the way, while I'm here, I think I did mention this on like the intro video thingy, but I am on Discord pretty much all the time. It's really easy to get a hold of me. And so you're... Ooh, you got a Malinois. Very nice. What was I saying? Oh yes, it's easy to get a hold of me through this. Generally, I respond to emails also pretty quickly, but that's definitely a slower way to go around it. So Discord is always easier to get a hold of me. So, because I'll see it pretty much all the time. So, especially if it's a fast question, like, you know, hey, what chapter are we on? That's very easy for me to do here. So, and also, Discord does not need to be... you do not need to be formal or anything. I do not care about grammar or punctuation or whatever. I certainly am not going to be capitalizing my sentences on Discord. I just do the stuff as quick as possible. Yeah, you're welcome to do this. Okay, let's have a look. Someone said something in chat here. What did they say? Ooh. Okay. I'm not able to chat. You've added yourself to the channel. Make sure you're in this general channel here. So make sure that you're clicking this one. You might still be in this one. Once you click the general channel, you should be able to type. And if not, I can maybe find you and add you directly. What name are you using in Discord right now? I can try and add you manually otherwise. Awesome auto. Okay, yeah, give it a shot and we'll see. So, as soon as you click the camel, you should have access to the channels. You may just have to, if you're on your phone, by the way, you will probably need to swipe and then you'll have to go down here. Usually, I think for the mobile interface, it's swiping to the right is the way to do that. Which I can never remember. Is on Tinder, is that the good one or the bad one? Swiping right. I don't remember. But that's okay. Oh, here, in fact, let me... Aha. So you see I swiped to the right, and poof, here are the channels, and we can go ahead and click them and see all this stuff. So you'll start at the welcome channel with the camel thing, and then you will click the general tab here. That's the one highlighted in white. That's the one that we're going to be typing here. Ted has teeth, apparently. Oh, I'm guessing that's a typo or something. Swiping right is the good one. Okay, then yes, we're going to swipe right on our Discord here. So there we go. Yeah, I'm fairly new to Ridgecrest. I only moved here last July, but it is nice to be a lot closer to the kind of nature-y stuff here. I just love how quiet it is. I'm from LA, so I am very happy up here in Ridgecrest, so nice and quiet, except for when Creature decides to start borking. Lisa, I'm going to go ahead and change your name here. Alrighty, cool. Oh no. Yeah, we'll save that. Okay. Oh, it was not a typo. It was in fact dentistry. Oh my gosh, Lisa, I may have taken away your privileges. Hold on. Oh no. Oh no. Let me fix that, Lisa. Sorry. Okay. Okay. I fixed it. Oh, you see. Oh, okay. So I think you're at the top here. So you want to kind of scroll down a bit. You want to hit the general that is this little pound sign or the hashtag. And that's where you want to do that. And that's where you should see this. Oh, awesome. You guys took physiology last semester? Eventually, I'll be teaching that as well. That'll be an interesting thing to have students in both kind of classes here. But we'll see. Were you able to get to the general chat? Belong6208. Let's see what the 113 students are saying. Oh, it's just me. Never mind, that's not as exciting. Alrighty, well, hopefully this will be working out for everyone. Yeah, exactly. Emily, you'll have the entire week to do it. So, your homework and stuff. Yep, Amber, I'll be uploading it to YouTube right after this. Usually they'll be up around 1 o'clock in the afternoon, just because it takes some time for YouTube to like upload them and process and all that stuff. They'll also be on Twitch, so you can just okay. And then let's see. Can you just type out what your name in Discord is? Belong, all that stuff, and I will try and manually add you. Are you at least in the welcome channel? The YouTube channel is going to be on, yes, Molly, it is on. The YouTube channel will be in, Canvas. That's probably the easiest place, but let me go ahead and find it anyway. I can get that to you. Where the heck is that going to be? How do I do that? Aha. Okay. Okay, I will link that in Discord for whoever. Okay. So let me try and find you. So Arlong 1984 or 84. Let's see. I'm not seeing you in our server. Angela? I do not see any. Maybe just try one more time. Click that original link and see if you can't get it there, because I'm not seeing your username anywhere on this. However, let's see, Arlong 84. Let's see if we can't find anything. Nope. Just try again, maybe. We're gonna fix this. we're gonna fix this. All right, I have an idea. I'm going to send you a link through Canvas. All right, maybe that'll work. How do I find that? There it is. Okay. Yeah, it should be the camel. As soon as you click the camel, you should be given access. So, we'll see. Wait, are you Rebecca L? Ah, you are. Okay, okay, okay. I can fix this. Okay, I can give you the role manually. We'll just do that. Okay. Okay, you should have it access now, Rebecca. Or Becca, I guess, as you prefer, maybe. Check it now, see if it's working. And if it is, then hooray! Awesome. Okay, so you should be able to type now in that general channel, and that should work. Obviously, there's not going to be anything on YouTube right now, by the way, for you guys. That'll be for uploading later. However, the stuff on Twitch, I think, becomes available as soon as I stop streaming. So as soon as it hits 10 o'clock when I stop, it'll work for you guys. Okay, awesome. I see you can type Rebecca. That's great. Or Becca, I guess. Whichever one, or whatever you prefer to be called. So, awesome. Cool. Hooray! We did it. Alrighty, yeah, so just to say one more time, there is no in-person requirement. You do not need to show up 9 o'clock. You know, never going to be a thing. So whatever classes you have or work or whatever, totally not a problem. You just watch stuff later. And if you have questions, throw them in Discord right here where everything else is, and I'll try and get to them. And that's pretty much it. So no homework this week probably, but next week we'll have something. It'll be due Sunday at almost midnight, 11:59. And yeah, so with that, awesome to meet you guys. And yeah, so tomorrow we'll continue on with our chemistry. We'll talk about chemical physical properties. Awesome. Alrighty. And if you guys want to know, I know that whoever it was earlier was asking, if you guys want to know anything about me, I'm happy to answer stuff as well. Throw it in Discord, say, hey, you know, what's your favorite thing to cook or whatever. I'm happy to answer. Yep, for us it'll be the same time, 9 o'clock, Monday, Tuesday, Wednesday, sometimes Thursday. Nope, those will not be due Sunday. Those will be for next week, Amber. I just have those posted in case someone's really crazy and they want to just start reading the textbook and go ahead. No, that's okay. I know you can only do it every 60 days, right, to change the name. So it's funny because when I have my name on Twitch is Chemprof, right? And so when I'm watching my other friends' stuff, they're like, who the hell is this? So, okay, yeah, no worries. So yeah, don't worry, Amber. All that stuff will be, that'll be for like 2 weeks. So yeah, if anyone wants to go get ahead of stuff, you're always welcome to do that. So, yeah. Alrighty. And of course, if there's any other questions about like class stuff, you know, throw those up as well. Yep. Awesome. Yeah, the first couple days are always kind of like troubleshooting and getting stuff going, and of course the internet goes out, and it's always fun. Awesome, awesome, awesome. Nice to meet you, Michelle. Alrighty, well, that is it for today. I will see you all tomorrow if you want, or if you can. Other than that, I will see you through my videos, and we'll get to you then. So, see ya. Oh, by the way, all our lecture notes, I will show you where I put them. Simply because I can upload them directly to Discord. That's where I'll be putting it. Oh my goodness. Let's see. Yes, here they go. Yep, see ya. So that should be there now. Of course, that other stuff is from last semester. If you really want to look at last semester's notes, you're welcome to. But that is there for you guys. So it's just right there in lecture notes. You can download those. You'll have whatever I write as another resource for you guys. Alrighty. See ya.